Well, hello everyone. I'm back. So it's Nono here. For those of you who don't know me, this is Nono Martinez Alonso. And this is the first live stream that I do after the summer. So I postponed the time to get started back a bit more than I would have liked to, but this is the kickoff of the new season that we start. It's been already 38 live streams, and this is live stream number 39. If you've seen anything online, as it says here, this is the Nono MA live stream. I usually call these things Nono MA live, and I want to believe that we talk about creative coding, machine intelligence, art, design, and many other things. One of the things that I'm most interested in is lifestyle optimization, which has a lot to do with my podcast, Getting Simple. And because of the nature of my daily job, right, I'm a software developer. I do a lot of hands-on coding here, and we're trying to create a community here of people that are interested in similar things that have to do with lifestyle hacking or life hacking, machine learning and AI, creative coding, and anything that has to do with art, design, and the creative fields. Today we have an agenda that we'll talk about more later, but it says hello world because it's kind of my way of saying after almost 2 months that I'm back. AI sketching, this is a topic we've seen through many of the previous videos, but we haven't really got to like a clear place. And then we have the ML course. Before I continue, I'm just gonna check here. It seems like there's video and there's audio, so for those of you who are online today, I want to say hello, and also maybe let me know if you can hear me, if you can see me okay, if everything's smooth. I can see online Sodivias and Ricardo Cesar Rodriguez. Thanks a lot for joining, for being back. I've interacted with both of you many times. I know that you both are some of the top collaborators or contributors to the Discord community. Anyone who is not on the community, you can join here at nono.ma/Discord. You'll have an invite to join. It's called the Getting Simple Discord server. And yeah, I don't know. I guess I've started early enough for you today, so DBS, it's always late for you in China and Asia. Okay, so again, hello everyone, it's Nono. For those of you who don't know me, Nono Martinez Alonso, and I'm gonna go through a few slides that I prepared for today. And just to say, today hopefully is gonna be a light live stream. I don't intend to do a lot of hands-on coding today, even though we can get into some things depending on how much time we have. I see here Ricardo says video and audio are okay, so we're good to go. All right, so let's switch to Keynote and let's see what we have today. Just a quick reminder, if you're watching this, liking the video helps this project. And if you want to get notified when I go live next, go on, subscribe and click that bell. The community, as I said before, there's a QR code there to make it easier, or just go to this URL. And this is the last live stream that we did. So we cover scikit-tsne or TSNE clustering algorithm that allows us to do dimensionality reduction. It was live 38 and it was July 22nd, and I didn't know that it was going to be the last live stream of the the summer or that period. Any live stream, if you want to go to live stream 1 or 2 or 3 or 38, you just put nono.ma/live/ and the number. So nono.ma/live 38 will take you to the YouTube video of live stream 38, and there are short URLs for all of them. Hello Bob, nice to see you online as well. Glad to see you guys connecting. And the first thing, so let me hide myself. So the first thing that I want to show today is something that you might have seen online. I've posted it many places, but I'm excited about sharing this work because I'm trying to do more film related work. This was a collaboration with Periferia Films and Daniel Natoli. He's a really good friend of mine that does awesome work. So I'm going to hide myself from here, and we're going to play a short movie that just takes I think 1 minute.
I wouldn't say that I try to convey anything in particular. It's more like a path to understand things, to see the world around me and understanding it. The drawing is like dancing geometry that things they missed out. This is a beautiful metaphor that really expresses the feeling of drawing. When you perceive things as blurry, if you draw them, they become crystal clear. It's like exploring. That's what really means to me.
Okay, so that worked. I'm surprised that nothing went wrong. So I hope you liked it. So this was it's a teaser video, dancing geometry. Yeah. It's a video that features Ruiz. So this is a, the full podcast interview is already released on the podcast feed on the website and on YouTube. But what we're going to release that is new is a full-length interview on video, right? So that's a video that features us both. We had to wear the masks because of COVID and these things. But yeah, so really, really excited about this project and about the possibility of record more of the podcast interviews on video completely. The latest episode that we released, I'm working on the following ones. It's Bytes Style Gun. So this is the Bytes series that I've already talked about on the podcast. Aziz Barbar is my co-host in this series inside of the Getting Simple podcast, and here we comment a bit of high level about the implications of NVIDIA in our culture and what technicalities maybe some people that are not super techy or tech savvy might pick up, right? So it's like a 10-minute episode, like pretty light, easy to listen, shorter than others. And as always, I would invite you to submit a question about this or any other previous episode to the podcast. I'll try to answer it with my voice recording. And you can just go to gettingsimple.com/ask and record there. What else do we have? Okay, so Bob is here with us. He's online. So I borrowed this GIF from a repo that he shared on the Discord server. This is a paper that was submitted to SIGGRAPH 2021, and it's called General Virtual Sketching Framework for Vector Line Art. The name of the authors, for me, some are hard to understand or to pronounce. Mo Hauran and Simo Serra, Edgar Angao, Chenji Anzu, Chakin and Wang, Ruo Mei. Hopefully I pronounced something okay. So this paper promises being able to trace or vectorize the main sketch lines of a photo or a drawing, like here, a hand drawing or like a digital drawing. And then another network is kind of examining each of those strokes, trying to reproduce them or trying to draw them, which, it seems really promising. I haven't tried, but this is something that I'm really interested in because this is definitely like a good companion, right? For somebody who's drawing or sketching. Imagine that you can maybe join the game if you're sketching by hand on paper with a webcam or something, or maybe in another medium, and then this machine interprets what it thinks that you did with your drawing. And there is code released on GitHub. Let me actually paste this on the... Do I have access to the Discord? I do, but I'm not gonna open it right now. So I'll make a list on my desktop, so with links, and I'm gonna paste a link to this. It's already there. Now that I think about it, it's already on the repo, but maybe, well, let's just put it. so we don't forget. General virtual sketching framework for vector line art. So one of the things that happens with the live stream is that I have a hard time choosing topics because there's so many and it's a bit overwhelming for me to decide or narrow down just in one of them. But we'll get there. I'm gonna post the link on the YouTube channel so you guys can click on it, the people who are watching right now, and for people who are watching later, you can find that on the live chat after the fact. Okay, so let's keep going. So what are we doing today? I always bring this slide. I mentioned before the hello world. That already happened, so it's just me saying hello and saying that this is back. There's not gonna be an end to the live stream. I actually have plans to make more of them and maybe integrate them a bit with the whole project of the podcast and trying to create more audio visual material. But I do need help from somebody who can, like paid work that I can help, that somebody can help me post-processing and editing the tutorials and the videos that I'm producing here, because I have 38 live streams and I have only been able to go through so many of them myself, even with the help of this script that has AI and machine learning. It's overwhelming to like cut the videos and export them and choose a name, a description, a cover image, and you probably know what I'm talking about. AI sketching, we already saw that, but that doesn't cover the topic. I would like to really get back at this project of building like an endless canvas in a web interface, probably, that we can use to draw collaboratively, and then from there trying to get back features from Pix to Pix, so from the suggestive drawing project that I created 5 years ago. And the ML course, that's also something that I'm trying to see if we're going to be able to allocate some time to record machine learning basic tutorials, like how to write TensorFlow and Keras code and tensors and data processing and things that have to do with PyTorch and anything that has to do with like getting started with hands-on coding and also the conceptual ideas. The course that I've dubbed is really generic, is Intro to Machine Intelligence for Designers. So I'm dubbing that title because I think that would make it into the topic that I want. Another possible title that I have in mind is Intro to Machine Learning for Creatives. That's something that maybe grasps other kind of people, but also requires a different set of tutorials. I think oh, hello Bea, so nice to see familiar faces. We don't have anyone new today because I have announced only through the channels of the people who are already following. I haven't posted, but probably I should on other social platforms. And Rob Beal says Colab drawing in web sounds super interesting. Yeah, I never got to port the iPad app of the suggestive drawing project, so the web probably is the way to make it super accessible to anyone who has a computer and do that. So Bob, do you, or for anyone who's online or watches later, what title do you like better? Can you write it there? So I said Intro to Machine Intelligence for Designers. The other one is the same but with creatives. So Intro to Machine Intelligence for Creatives. And yeah, I don't know. I guess we'll have to think about the title, but I'll start getting videos as soon as possible out. All right. So define top level goals for the live stream. I put this as a task that I need to do. I have here a document that we have seen many times. This is my backlog for what we've been doing on the live stream since day one. Right here you can sort of see the ideas of each of the live streams, and one of the things that you could see, okay, first one, I get it, the designers one. Okay, and so we have here, even from live stream 3, we have the idea of recovering back the suggestive drawing app, and we did some live streams there. We wanted to upgrade the Xcode Swift project to latest version to see what was already built in there. So I'm hesitant of starting to build a web only app or trying to recover the iPad app, but the web version seems like something that would be more fun, because even people who are on the live stream could, interact live. So we have the data set. So I already have a lot of data that could be used. We have the machine learning model that was pix to pix, but of course there's so much that has happened since 2017 that we could use many other things, like Sketch-RNN, or what we just saw today, which needs probably a more catchy name, something short. The client app, this is like Canvas with layers and connected agents, or like collaboration. And then the server has to be running somewhere, right? Like we can either execute models on the tab, on the web tab, or on the cloud somewhere. And I think on the cloud makes a lot of sense, because that way the client gets to be a lot lighter, right? What was I going to say? Yeah, so another thing that I wanted to do, so for the top level goals, one of the things that I want to do is try to actually create some more sense of community with you guys and with the people who watch or are interested in these things. So foster the community. And for this, something that we can do is we could actually get to do live Q&A on the live stream, which is different from something that we could also do, which is a live Q&A on the podcast, which at the end would be the same. It would end up being Zoom calls, but they're two different sides of the things, and I don't know if they're easily separated or we could just do them on the same call. But this would be like a Zoom call where anyone can join, anyone can talk, and we can all interact. One thing that I thought is we can create a calendar. This is something like Jose Luis Garcia has as well. So he has a calendar and schedule things. And for me, it's always been Thursdays, but there is no sense in advance of when these things are going to happen. And if at some point I want to schedule a call or I want to schedule a live stream that is not on Thursdays, we could just see it on the calendar and people could allocate their time better that way. Okay, so we've gone through more or less 20 minutes, and other goals that we want to do is like create an introductory machine intelligence course. Create an intro machine intelligence course, right? So we've talked about the potential titles. So this could be like intro to machine intelligence for designers. That seems like a good title. And contents would be, contents could be AI and ML basics, frameworks, right? That will probably focusing on TensorFlow, Keras, PyTorch. It seems to be like what people are using the most. Then like tensors and data manipulation, which includes also images and data frames, etc. Yeah, so Ricardo says that Google Calendar is great because Alexa can remind him of when the live streams will be available. Yeah, that seems like a good way. Like I'm not sure how I could share calendars with you, maybe just on my Google Calendar, or create a specific Apple calendar and share it publicly or something like that. That sounds like it should be fairly easy and fairly doable. Okay, a question I have now, at least for the 2 or 3 people that are online, do you prefer longer live streams or shorter live streams more often, right? Like one live stream of 3 hours, let's say, every Thursday, or 2 live streams of 1 hour or 1 hour and a half every week. because that's something, you know, for me, doing this for 2 or 3 hours on Thursdays is a big time commitment. But maybe if I split that in different chunks, we can accommodate for the time zone of different people, and maybe also for different topics and other things. Okay, so yeah, so these are goals, and so maybe not in red. So these are goals, so we can put them in green, and here can do two things at once. And then we have to-dos that are more actionable things, right? So calendar, publicly available, choose between Google Calendar and iCloud. And multiple live streams, hard not to be interrupted. So multiple live streams throughout the week that are shorter, right? Because you don't, as I don't, right? You don't have the time to be there for 3 hours at a time, right? And maybe shorter things could be better. Okay, decide on tentative weekly schedule of multiple small live streams. Also, you know, the doing one live stream a week is because, you know, you set up the time, you just start recording and then you start going. And yeah, shorter live stream is better too. Yeah, I think, I mean, that makes sense, right? That's even this live stream that I'm doing right now, we could split them, right? We could have different chunks and then keep going with the second part. But yeah, thanks guys for your, you know, for your feedback and your input. How does this project sound for you? Like the thing of trying to build like as an overall goal for the live stream, right? Like as a goal for the next months or something like that. Actually put another goal that says here, like build an AI collaborative, so let's say a collaborative AI sketching platform. How does that sound? Like endless canvas, collaborative, human bots, drawing, and machine learning suggestions. Does it sound good to you? I mean, this is what I've been saying that I was going to do forever, but I always get distracted with other things that are more pending. And this could be the main line of work for okay, so we can ask if there are other ideas or like how we can shape this project, but I think what I'm going to do is just focus on these three, mainly on these three goals, even though there would be other things in the middle always, right? Like I always, there have also been things that have to do with web development, not only with machine learning, but those things also help support this, because build a collaborative platform. And we can put here accessible through a accessible web client app or web app, right? So that will bring us back to web development sometimes, because we still need to do that. And another goal, this is more for myself, is delegate video post-processing. And yeah, so this means externalize or like find a video editor. So delegate a video post-process, like video editing, and in this script uploads to YouTube, creates cover images. Nobody has time for that. I don't. I think the key thing is to make explicit ways people might riff off of the main project. Yeah, so that's true. I mean, of course, there will be a main project, right? Like the main project, and then we'll do chunks or like different separate things that we'll try to integrate in the project. So for example, we can one day can just be the AI sketching paper that we showed today, how to consume that one, or a series of days, how to train it or how to consume it. And then we'll have a part to integrate it on the app, right? What I'm going to try to do is to think of the software architecture of the app and see how to deploy it to the web so that people can use it. May do a read that uses model-based reinforcement learning to CS assistant. Yeah, that would be awesome. Like if this is open source and other people can collaborate, so maybe we put that here. So open source and extendable by the community. That would be great. I mean, that would be awesome if people start building on top of it. I mean, that brings back to the, if we have like maybe like a bot or like prediction. So let's say prediction, yeah, AI. So intelligent suggestion protocol to allow others to easily develop for the platform. Yeah, that sounds really good. Okay, so I have this goal here, define top level goals for the live stream. So now that you're here, the live stream also, let me just time and shoot. So the live stream also has a lot to do with the podcast, right? So I haven't explicitly done a lot more than recording parts of episodes during the live stream for the podcast. I think it was the looping music or looping playlist episode came out from a live stream. And would you be interested on any way on having an integration of the podcast, maybe live interviews or some other sort of podcast content created during the live stream, like something that we could probably bring here to the channel as well, and maybe have people interested or interacting while maybe I talk to a guest informally, or maybe while I explain a topic and try to record a podcast episode. That might be a more boring format if you want to see hands-on coding, right? But if you want to be an attendee of a podcast and maybe interact with it live, that could be a good like a good format. Yeah, sketching subdomains that skew less artistic, like UI sketching. Yeah, I mean, UI sketching could be an option. I'm imagining that there could be agents, right? And yeah, and there could be any sort of agents like reinforcement, learning agents, or like pigs to pigs, or UI sketching, anything that you can imagine through a protocol where you're just sending maybe text, strokes and fills and images maybe. Like if you want to send an image with pix to pix, right? Yeah, awesome. So, okay, so I don't really have, so we have the ML course that we already talked about, the AI sketching and the hello world. So I don't know what we can do now. So I'm gonna take a quick break, and we'll be back. Maybe we can, maybe we can take a look at that AI sketching code, and maybe review a bit of this document a bit more to see where we have parts that might be useful. And I think I need to do some investigation on my own to see what technologies we can use to build this thing. But yeah, I have some ideas here. Okay, so let's take a quick break. Thanks a lot for being there, guys, and for your input, Rob and Ricardo. And I'll be back. All right, 2-minute break. I'm back. So anyone there still? Let's code, or let's try to see what we can do that resembles a bit coding so we don't rust ourselves. Okay, let me just browse through. So let me open the tab. All right. Okay, so Rob says here, let me just pop out this chat so people know what I'm talking about. I don't really like this chat that much. I think they could design it a bit better. Really excited that you want to invest in this. I'm going to help, just need to assess how I can best do that. My videos take up a lot of my time. Yeah, so any type of input, any type of help, or anything that you think that might help, or that you can submit to the Discord, right? So I'm gonna make a shout out there to the Discord server. It's coding time. Yes, Ricardo. I don't know what we're gonna code. I don't have that much time today, but I definitely wanted to kick off the series, so I get back and running. All right, so this is the Discord server, right? So this is the you can see here it's called Getting Simple. Like the podcast is just because I have a few projects and I didn't really want to have to do different Discord servers for different things, and it's all united. So for anyone doing things here, you can go to the machine learning channel to put links or learn more or things like that. Share your projects on the shared channel. Introduce yourself in the introduction channel, and we have a members log, like people are joining many times, and yeah, so you can also put topics here. So one of the ways in which anyone can collaborate is suggesting topics, suggesting ways in which we could continue this project, and maybe when we have a more clear idea of what we're going to end up doing, we could make I could prepare a few slides and make a proper presentation of the project, right, to kick off the project and to actually get to start building it. So we have these 4 goals, right, that we have put in here. I don't know if I can span them all and see them in a slide. They're a bit big. Yeah, so maybe we show these goals next week. So we'll put them here. All right. And we can change them, we can comment on them, we can adjust them, but yeah, so these are the main goals that I could think about. All right, so let's bring that back and let's go. Let's do some coding for real, or let's try. Okay, so I'm gonna close Discord so you can go to the YouTube channel and keep typing there. And so first, let's open back that repo that we had before. So this was the general virtual sketching, right? So this is their publication. So this is where this is the example that I grabbed, and there are more. So if we go to the paper, we'll see the neural network architecture, which they have here as well. And I don't fully understand because I haven't read the paper, and some of these things actually get out of my understanding of machine learning. But what seems to be happening is that there is a step in which we have this sliding window, right? So we have a sliding window that moves and tries to plot different points, and it tries to generate the strokes. It tries to vectorize, and we have the like another model that renders, and then it pastes back on the window. What I don't know is how they, or if they sketch, so stitch those together, right? Because as you can see here, there are different parts that are being captured by that sliding window, and then they get pasted back in place, right? And it seems like it's trying to connect different points together at the end to make a cleaner path, right? Sequential strokes in the canvas. And there is a CNN encoder, so we encode the drawing. We get like a feature. Is there a definition of what that one is? So this is Not here. Decoder, hidden state. Okay, I guess. Okay, let's. Oh, the presentation is on YouTube. I watched this video, which I recommend you see. This is what we saw before. These are other examples. So you can see this one also works pretty well. This is surprising because this is actually a hand sketch with a pencil. This one. And these two, which is trying to simplify a face or make a sketch of a face, which is it's pretty cool. And here more results. This one I haven't seen. I'm gonna turn volume off. I don't know if this has audio. But yeah, I saw this one. So these are clean drawings, right? But then later I think they show. Well, these are raster images of drawings that should be easy to vectorize. And this is sketch. That one. These ones are really cool. That this works. Okay, and these are just more examples of the same pre-computed results, presentations. All right. So let's open the paper really quickly before we go to the code. And let's see. Would be great to touch base with these people. So giving clean line drawings, rough sketches of photographs of arbitrary resolution as input, our framework generates the corresponding vector line drawings directly. The framework models a virtual pen surrounded by the mind window, red boxes which moves while drawing the strokes. It learns to move around by scaling the window and sliding to an undrawn area for restarting the drawing. Modern examples are in directory in a blue arrow. With our proposed stroke regularization mechanism, the framework is able to enlarge the window and draw long strokes for simplicity. Right, I guess I'll have to review the paper on my own. Okay. In our framework are represented in relative manner, continuous stroke, which is similar to the 3-stroke format in Sketch-RNN. Alright, so we are familiar with this one. We've covered it on the live stream and other videos. If you want to learn more, so I think by putting here Sketch-RNN, Nono, YouTube, yes. This video, which I'm gonna put also on the links. So I'm gonna put on the links. Where are the links? Here are the links. All right. So right. So I have this video on the channel, and maybe let's put the link on the chat. So this video I did a while ago for 2018. It does talk about the encoding of the strokes in this way, right? So this is for Sketch-RNN, and here we even have an example of the encoded strokes and examples of things generated with pix to pix, right? So yeah, so this is a one one hot vector. This is x and y, so this is the each step is like the delta, like how much you moved from the previous point. And then we have this one hot vector on the right, that if it's 1 0 0 or 0 1 0 or 0 0 1 means three different things, right? The first one is that the pen is touching the paper, a line will be drawn connected to the next point, and 0 0 1 0 is that the pen will be lifted after the current point, and then if it's 0 0 1 means that the drawing has ended and no more points are going to be drawn and the drawing is finished, right? Okay, so that video is there, the link is also there, and okay, so let's see what else is in here. This seems like the Sketch-RNN dataset, Google Draw. All right, a lot of stuff. This will take time to review, but I'm going to move now into actual code. I don't know if we'll have time to code, but at least we're going to take a look at the code, at the repo. Right, so we go to the repo here on GitHub, and already 6 forks. All right, so uses TensorFlow. Why? Why are they still using TensorFlow 1.1, 1.12, 1.15? They might have been developing this for a long time, because using this is like, now we're up to TensorFlow 2.4 point something, or 2.5 or 2.6. I don't know how many versions they released in the summer. So 2.6.0 is out on August 11th. Okay, maybe there's an opportunity here to port this model to TensorFlow 2 if it's not too hard. Download the models here. Among works that do not require training vector data, learning to paint is the approach closest to a framework, albeit with some noticeable differences. This is great. If you can send me highlights of the paper that are relevant, this is awesome. Thank you. And this one said by Rob. This is another paper. First, we adopt a continuous stroke representation instead of a discrete one for more natural stroke continuousness, and we use Virtual Pen, which can avoid the redundant drawing problem. Second, learning to paint is limited to a small fixed image size with our handles images of arbitrary resolution. That's awesome. Okay, so the models are here. So these are the data sets. Quick draw, right? That's what I was looking for. Yeah. So quick draw all our results. I'm gonna download everything from here. And okay, so we have then place them in this file structure. Output snapshot, blah, blah, blah. Choose the image in the sample inputs directory and run one of the following commands for each task. The result will be under output sampling. Python 3, Mutant. Okay, do we have a requirements.txt file? They don't have it, but I guess we can get it from here. Okay, so I'm not sure if this is gonna be hard or not, but I'm just gonna I'm gonna clone this repo. So first thing we do, git clone, and we open it. So we're gonna edit that in Visual Studio Code. I'm starting to run out of time. And okay, so we're in virtual sketching. Now we're gonna create a Conda environment. Believe it or not, I have forgotten some of the commands over the summer, so we are gonna do create a new environment, and I have some cheat sheets here. So Conda create name virtual sketching, so be sketching, and we're going to install PyKernel, and we're going to accept everything. All right, so this will create a new Conda environment without our dependencies, but we'll install them later inside with pip. And for that, we just need to now do Conda activate. When that's resolved, be sketching. Right, so that's still being resolved, and we're gonna get back to see our dependencies. So TensorFlow, why don't you tell me exactly the dependencies that I need? Okay, so for, I mean, I guess you guys are familiar, but usually you put on your repo a requirements.txt file that contains the things that have to be installed, and you can just do pip install, I think, requirements.txt, and then that will install of your requirements. So I'm gonna do here requirements.txt, and I'm gonna put TensorFlow. For example, I put here TensorFlow equal to I can just do 1.15.0, OpenCV 3.4.2. I think we can actually just copy this. So let's actually do requirements.txt and see if we can simply paste that and install. Okay, so we have, this is the okay, let me actually edit this folder here, and okay, so we have this thing here. We're going to do this. Let's try this out. Let's see if this works. I'm not sure if this is gonna work, but we'll do, well, which pip. So pip install requirements.txt, and that should work, but I'm not sure. Well, this says that we need Python 8, 3.8. Doesn't say. Could not find a version that identify the requirement. Let's see. TensorFlow 15 not supported. Let's try this. Well, here we have the first roadblock. All right, let's try in Colab. I don't know when this was edited, but right, so that exists. So let's try this. Right, these things happen live. Yeah, so I'm just trying to get the I'm just trying to get the these things to work, right? So we can actually call the sketch simplification and I guess, yeah, with the train weights, come back to the code at another time. Yeah, that's probably a good idea. But I'm just gonna try once more here. Pip install TensorFlow 1.15. Nope. Okay. Yeah, okay. So it works in Colab, it seems. It's installing the TensorFlow that we need. Let's see. See a version. All right, so we have it here. So let me see. So you said the testing with train weights. Yeah, so test vectorization here still requires TensorFlow, right? So that's what we're gonna do. But we're not gonna train right now, but we're gonna do it in Colab. So All right, so here we do have TensorFlow 15, which is what we need, so we can import it. And what we're gonna do is that we're going to clone this repo here. So git clone that, and then we'll do okay, so that worked there, and now we do need to this download all the files. Okay, so I've downloaded the pre-trained models as Rob has said, and I'll put here that link as well. Well, that link is on the repo, so we don't really need to put it there. So we'll just see the links file. So okay. So you have the drive, pre-trained models used for testing, clean line drawings. All right, so this one we're gonna see it's a file. These are the train weights. This is the model config. Okay, we probably need to upload this thing to Colab. So we download. How was that? Okay, let me just see if this is not too slow. Okay, where do we have to extract that? So it says place them in this file structure. Outputs. Okay, that's not it. Testing with, okay. Download the models here. Pre-trained clean drawings for vectorization. So that's pre-trained clean drawings. And we have the C file here. Place them in output snapshot pre-trained. Okay, outputs snapshot. So we're gonna go here and say, okay, make a dir, it's gonna be outputs, make a dir, it's gonna be outputs, snapshot, and then make a dir, there's gonna be outputs, snapshot. Okay, let's see if that gets created. Oh, it gets created there. Okay, so but we need to do it in virtual sketching. Okay, so we put it here and then we run it there. Okay, so we get outputs, snapshot, pre-trained clean drawings. Okay, so we just need to, I mean, these are really small, so we're gonna upload that directly. That's already there. And now we need this one, that is the big one. So we are gonna try to do that. Otherwise, we'll have to download them with another request, and that's uploading there. All right, let's hope that that's not too slow. And now we're gonna get back here. We do need to install the dependencies, so we don't have Pillow, OpenCV, SciPy, and GSE. So let's try to build a command for that. Command call for that. We'll just do this, and again, just put this like this, and that should be pip3 install. All right, let's try. Let's try that. So this is gonna take a bit to upload. Let's see, the models are here. So get link. Okay, bear with me. We're almost there. Let's see if this works or not. All right, so okay, let me look for something here. I'm just trying to look for a code to download files before I. Okay, so we'll do wget o, I don't know, 0 o, and we'll do it virtual sketching outputs snapshot pre-trained clean drawings.zip. Okay, let's see if we can download that file from Google Drive. No such file or directory. What? Okay, the other way. Alright, so this is a bit messy. So this is uploading, but let me see if we can see this properly. So I'm gonna be moving this URL here. So we put the, so we're putting here that we're downloading here at this zip path. We're downloading this file from Google Drive. It's all being saved. Alright, so it seems like it's been saved already. That was pretty fast. Okay, so that's here. Now we can actually stop our upload and we can do unzip pre-train clean line drawings.zip. Then we can go to virtual sketching output snapshot pre-train clean line drawings. Cannot find or open blah blah blah. Let's see. Okay, where we're at is content. Okay, so we need to go to virtual sketching output snapshot and then list files. And here we see this, so we just unzip that. Archive, enter, identify the fields, no C file, consider the multiple archive in the later. Okay. Download files from Google Colab, Google Drive to Colab. Maybe it doesn't work this way. Okay, so I'm gonna just put it on Dropbox temporarily. Inbox. That should be fast. All right, so we have a Dropbox link now for this file. So I have it on my other window, and we're really close. Okay, copy link. So we're gonna get that link, and we just need to put that here. Let's try again. Okay, so that's downloading now, and supposedly this is going to be able to unzip it. Conflating. All right, so we did that. Again, they went here, which I guess is okay. Just move that one there. Right, seems like the model is properly uploaded. So, and I'm not sure if we have the right dependencies, but if I do this and then I run that and then I do this. Okay, we're on the repo. So it seems like we're able now to run the command. And if we don't, I'm gonna call it a day and we'll see. So Muten, do we have Muten? So sample inputs, what do we have? We have clean line drawings, and then there we have Muten PNG. All right, so let's try this out. So Python. Pre-trained rough sketches. Okay, so that's not the one that we're using, right? So it's the clean line drawings. So that probably is this one, test vectorization. Oh, it's good that we're getting that failure because that's easy to fix. Okay, let's see. Fingers crossed. Right, and I don't have the chat, so I don't know if you guys have said anything. Oh, that seems like something's working. YouTube Studio, no comments. Anyone there? Okay, we have another no such file that to sample input, sample inputs. Okay, so the model is hard-coded as much as they could. Yes, okay, so input. Okay, it seems like it's gonna work. Now what we need to do, I'm gonna go to my sketch. No, I'm gonna go to my, what is this? I'm gonna go here and I'm gonna give it an example drawing. Let's try with this one. All right, let's see. All right, okay, so let me switch on the screen. I'm gonna get to download the Muten image just to see how it is, the resolution and things like that, to see if we need a specific image. So we have here clean line drawings, Muten. Okay, so this is big, and what about this one? I think they do have different resolutions, so we don't really, okay, I don't think we need to do anything to it. This is a PNG, that might be, okay, so let's convert the image that we have on our desktop. So this is this one, so let's convert it to PNG. right? No, sketch, and we're going to place that. Okay, so this is doing compute and stuff, and I'm not sure. I mean, it seems like this has saved already. So the sampling order, blah blah blah. So the prediction is here. Cool. I mean, so this works pretty. Was sort of pretty easy to make it work in some way, and yeah, nice. And this was the input, right? So you see that the input, the output is a lot cleaner than the input, and is exactly the same, which is really cool. I mean, there's some noise and stuff. Okay, so sequential data, order compare. And I don't know where the vector data is output to. Outputs. No, I did this one right. Okay, yeah, we don't know, but to conclude today, I'm gonna put here clean line drawings. We're gonna put Nono sketch. We're gonna put in clean line drawings. So we're gonna change this. We're gonna change this to Nono sketch, and we're gonna run it. And this takes a bit, as we saw before, probably also depending on the resolution. I'm not sure, maybe it doesn't. And it's running, so it's processing Nono sketch, image size 200 500. Yeah, I don't know, maybe this image is bigger than it needs to be. Let's make it a bit smaller and crop it. All right, so I made the same image now 1000 pixels instead of 2500. I'm gonna put it here. And we can run the same thing below. We'll run later with 1000. Takes long. I mean, this is one of the things that it's really slow. So this would be not something that we can use instantly. Conversion to SVG, our vector output. Let me bring this to the. Thanks so much. Rob, this really helps a lot to have these things here. Right, so you should give it a try with one of your sketches. Awesome. Yeah, thanks. Let's try that and see, maybe with other color. Maybe I don't really know. Yeah, we should try with some of the other models as well. But yeah, I'm curious about what happens if I give it a sketch that is not super polished. Let's try with this one. Right, so we have here pan, and we're gonna put pan here, and we'll do this. with pan when this one finishes. And let's see where the output goes. This is clean line drawing, smoothen, Nono sketch input. Well, I mean the input we already know what it is. It's here. It's a bit big. Yeah, it's probably too big for compared to the size of the others. Saving results, sequential data, Nono sketch, prediction. Okay, so I don't know what this one is. Sequential data MPC format. Is it NumPy? Okay. And here we could do I don't know if this will fail, but whatever. Okay, so this still saving results. Round lines. So this means that we have so we've exported a sketch that is way too big, so that this probably now is executing takes shorter. And I'm not sure what's happened, but this doesn't seem like it's saved. This one might be faster, I guess. Snapshot step. All right. Well, I'm gonna be closing. It's 7:30 for me, and I think this has been a really good catch-up live stream. We've been able to use this, and I'm sure we'll be doing a lot more. And I'm really thankful that you guys joined. You know why I was going to read this thing that I forgot to read from Rob, that he was messaging me on the chat saying that the conversion to SVG or vector output in an MPZ package is stored as EQ1 in the main paper. Run the following command to convert into SVG format. Okay, so that is exactly what I was looking for. So maybe we can open conversion. Maybe that's here. So Rob, the text that you pasted, so this, where does this come from? From the repo? Okay. I see on the repo, okay. So here, there, the conversion result. Okay, so I guess this will work right out of the bat. So it's gonna take a bit. Will you save the notebook in a way that we can play with a copy ourselves? Yeah, of course. We're going to do that. So let's do that before going, because that way we do ensure that everyone can GitHub really. Yeah. So I'm gonna sign in with the account that we have for the live stream. So and put my pass. So we're gonna create a new notebook. It's gonna be called virtual sketching live 39, and we're going to, the first thing I'm going to share this to make sure everyone has access. So change to anyone with the link, copy link. That's going to go also to the channel. And done. So that I'm gonna put here. Hopefully you can enter already. It will be empty. And I'm gonna just put these things here. Okay, so we download the model. We then, yeah, for me I had this thing to unzip. Yeah, this is it's better if we put this here. All right, can you verify that the link I put there is accessible by anyone? Should be. I mean, it seems like it's here, right? Yeah, okay, let's see. Yeah, so we get an MP3 file object, and what is this? Files. Okay, so let's try that. Let's just print sec data files. Awesome. So we have all of these files there. So we have the strokes data, and we could print here strokes data. List. Yeah, maybe. Oh. Right, so we would get here strokes data. Okay, so this is the stroke data. So we actually get, this is great. So we actually get the data of the okay, so inspect vector data. And to avoid this not working for you, I'll put this here, move 10, and then we'll print this, and we'll print this. All right, cool, great. So I'm gonna save, and yep, lastly, we're just gonna see the results just to see if this makes any sense at all. We have the sketch for the small sketch of mine, so we got the thing on the right, so it's pretty neat, pretty accurate. So it's pretty crazy because this means that this is a vectorized version of this. This is just hand sketched, and this is now scalable to any size. This is, guys, this is really good. This is really good. And we can try this further, but I don't need to save it. I want to save these sketches. So that's super cool. And let's see for pants prediction. Nice. Okay, so this is also really good. I mean, it's also a really good vectorization of the sketch. I'm pretty impressed. And these are the paths. Okay, so I don't know how it does it, but it's really good. And I'm just gonna save these images as a memory of today's live stream. And what's the difference with this? Okay, so this is the high resolution prediction. Well, that's really good. Okay, so I guess to recap on this, so we don't leave that aside. So let's make a to do test, vectorize drawings with virtual sketching. And we have here the blank slide, and we're gonna put these ones here. Okay. So I think it saves the images exactly at the same size than the originals. So I'm going to put these ones here, and I'm gonna save as well the inputs that we used. So we use this, and this. So you have that one. We're gonna close the others. We have this one, and we have this one. Yeah, exactly. Oh, exactly. That's not it, is it? Well, the canvas changes a bit, but what I wanted to do is like if I put these guys in here, right? They'll have the same relative size, which is good. So this one and this one can be grouped together. This one and this one. And these two, oh, they don't have the same relative size. Either way, whatever. Cool. All right. So okay. So glad you like it, Rob. So I'm gonna make this bigger. This one bigger. All right. So we have now these images, and we also got some other information here. So this info, I don't care that much about the mutant because that's not really my that's nice, the randomization parameter. That probably gives you a lot of leeway to iterate and get results that you like more. I was wondering about the order, probably like pretty stochastic. Okay, so that makes for a nice slide pattern. And all right, cool. And we'll just give credit to this here. Probably. All right, so I'm gonna do something I do often, and we're gonna wrap up. So this is it for today. I'm gonna make a cover slide in case that we get to edit this. Hi everyone, it's Nono here, and this is a quick overview on how we can vectorize our drawings in really high quality with virtual sketching. This is a recently published paper that we're gonna see today. And before we get started, I want to show you some of the results that I've obtained with my own sketches, my own drawings. So what you can see here, this is Mutant Roy from Dragon Ball. This is something that already exists on the sample of the paper. And what you see on the bottom is a raster image of what I imagine was a vector drawing or a high resolution scan. And on the top, you can see all of the strokes that have been converted in the process of running this algorithm. On the middle, you have a sketch that I did. And on the top, you have vectorization of that sketch with every single individual stroke in different colors. And I think the color mentions just different sets of strokes and moments in the drawing. On the right, you have another illustration that we use with the same vectorization model. And when you make a vectorization, the model gives you these diagrams in which you can see the order in which they were sketched, and also the the kind of the logic of the path. Like on the right, you have a continuous path for how it followed the drawing. You can see, get a sense of where it started or where it finished. And for everything else, it's just like, if you remove the parts of the drawing, like you can see in here, right? If you remove the parts of the drawing that are continuous and make the drawing be weird, like if you didn't ever put your pen up, you'll see something like this. So this is actually a sketch I did back in 2016 or 17 of Panagiotis Michalatos. And this is the vectorization. I think this is super cool. It's super easy to get it done. And this is, I think this is super impressive how well it works. And I'm definitely going to be using it more on the live stream and on my own projects. This is, I think I can show again. We showed this before, but the neural network actually, what it does is that it has this sliding window that it zooms in and out to look for strokes, and it tries to find the paths and vectorize them and then paste them back on the overall drawing and make continuous strokes, right? To name the paper, so this is called General Virtual Sketching Framework for Vector Line Art, was presented at SIGGRAPH 2021. I will thank Rob Beal again for sending this to the Discord server. So on the community, we have a channel where we can share papers, also the machine learning channel. And this was a paper as a result of work by Mo, Haoran, Simo Serra, Edgar, Angao, Chenyi and Zhu, Chanki and Wang, and Rome. Thanks a lot for putting this code out in the open. And without further ado, let's dive into the code and actually get to use this machine learning algorithm. All right, so that was my intro for what we've done today, because I didn't know how far we were going to get. And now, if you're watching this offline, because you guys that are online already heard this, liking the video helps me a lot. You can subscribe if you want to get notified, or click the bell if you want to know when I go live, and join us on the Discord server. We have a community and we're trying to foster it so we can create projects together and collaborate. I will especially thank Ricardo Cesar Rodriguez for being online today, and also Rob Beal. Thanks a lot, Rob, for extracting parts of the paper as I was coding to help me out and let me find things. And without further ado, thanks for watching, and I'll see you next time. Yeah, so Rob, I'm really excited as well. Kids, I don't have kids yet, but I'm sure, I know that they take a lot of time. So any help that you can put, even giving us pointers or things that we were doing today, like summarizing or trying to Google parts or find parts of the code that might help and might make the live stream more smooth, that's awesome. So thanks a lot again. I'll see you guys next time. And this was it. It was, as always, a bit longer than I thought it would be, but it's not bad. So I think it's good. Okay, thanks so much, guys. I'll see you next time, and thank you, really. Bye.